Have you ever wondered how your computer and a server seamlessly exchange data, ensuring every piece arrives perfectly sized for the journey? It is a bit like packing a suitcase, where you want to maximize what you fit, but not overstuff it so it breaks. Maximum segment size, or MSS, is negotiated during the initial three-way handshake of a transmission control protocol, or TCP, connection. Specifically, it is exchanged within the TCP options field of the SYN and SYN-ACK segments, which are the first two steps of establishing a reliable connection. This negotiation is crucial because it prevents packets from being too large for any single network link along the path, which would force them to be fragmented. Internet Protocol, or IP, fragmentation is generally inefficient, requiring more processing overhead and making retransmissions more complex. By agreeing on an optimal MSS, both parties ensure that their data segments fit within the maximum transmission unit, or MTU, of intermediate networks, avoiding this performance penalty. The process begins when the client sends a SYN segment to the server, including its proposed MSS value in the TCP options field. This value represents the largest TCP segment it is willing to receive. The server then responds with a SYN-ACK segment, also carrying its own MSS value, indicating the largest segment it can accept. Each side then uses the smaller asterisk of the two advertised MSS values, or its own local MTU minus the IP and TCP header sizes, to determine the effective MSS for the entire connection. A key underlying concept here is path MTU discovery, or PMTUD, which dynamically identifies the smallest MTU along a network path. While MSS negotiation typically defaults to the local MTU minus header overhead, PMTUD ensures that even if a link with a smaller MTU exists further along the path, the communicating parties can adjust their effective MSS to avoid fragmentation, often by using Internet Control Message Protocol, or ICMP, messages. Ultimately, the negotiation of MSS during the TCP handshake is a foundational element for efficient and reliable data transmission. It intelligently adapts to network capabilities, preventing costly fragmentation and optimizing throughput, ensuring your data travels smoothly across the diverse and complex landscape of the Internet.
If you love understanding how the web works, like, subscribe, and stay connected with us.